Today, we're going to pull back the curtain on some incredible invisible forces. These are the principles that stop our machines from shaking themselves to pieces and make sure everything from your car to the power grid runs with perfect, smooth timing.
Okay, let's start with a mystery you've probably experienced. You know when your washing machine hits the spin cycle and it sounds like the whole house is about to take off? But then you think about your car's engine spinning thousands of times a minute and it's pretty smooth. How is that even possible?
Well, it all comes down to one word: balance. That image on the left, with that one single mass off to the side, that's your washing machine with a lopsided load of wet towels. The perfectly balanced disc on the right, that's your car engine. The real difference is how they handle this incredibly powerful, unseen force that wants to pull everything outward.
So let's dive in and really get to the bottom of this. We have to understand that destructive shake first.
The culprit, the villain of our story, is something called centrifugal force. You know, anytime you spin something in a circle, it wants to fly outwards. If that pull isn't perfectly even all the way around, you get a wobble. And when you speed things up, that little wobble turns into a massive, destructive vibration.
This diagram here shows you exactly what's going on. You've got this mass, M, spinning around at a certain distance, R, and it creates this constant pull outwards. When there's nothing on the other side to pull back, it just yanks on the whole system, creating vibrations that can literally tear a machine apart over time. So how do you defeat this crazy destructive force? Well, the solution is actually beautiful. It's so simple. You basically fight fire with fire, using something called a counterweight.
And here it is. This is how it works. To cancel out that pull from what we'll call the disturbing mass, M1, engineers just add a balancing mass, M2, on the complete opposite side. It creates its own centrifugal force, pulling in the exact opposite direction. And poof, the two forces just cancel each other out. And what you're left with is perfectly smooth rotation.
This simple little equation, this is the golden rule of balancing. And it's so powerful. All it's saying is that the first mass times its distance from the center has to equal the second mass times its distance. If you get that equation to balance, you get a perfectly balanced machine. It's as simple as that. But of course, in the real world, things are a bit more complicated than that. You've got multiple masses spinning on different planes, like you see in this diagram. Engineers use that same exact principle, but they have to do some pretty serious math to make it all work in 3 dimensions for things like jet engines or these massive industrial turbines.
Okay, so problem solved, right? Everything's running smooth, we're done. Well, not quite. It turns out perfect smoothness isn't the whole story. A completely new challenge pops up, and it takes us way beyond just stopping the shakes. Just imagine this. You're driving your car. The engine is perfectly balanced. It's just humming along. But then you get to a really steep hill. The load on that engine suddenly skyrockets. What do you think happens to the engine's speed?
Yep, exactly. The engine's speed drops. It has to work a lot harder. And this shows us a really key problem. Balancing is great for getting rid of vibrations, but it can't do a thing to help an engine adapt when the workload changes. For that, we need a totally different set of tools.
And that brings us to our speed control dream team, the governor and the flywheel. Now, they might sound kind of similar, but trust me, they have very, very different jobs. First up, the flywheel. The easiest way to think about this is just a big, heavy wheel that has a ton of momentum. It loves to spin at a constant speed, so it's fantastic at smoothing out those tiny little speed changes that happen inside a single rotation of an engine. It just keeps things chugging along smoothly.
The governor, on the other hand, well, that's the brains of the operation. It doesn't care about the tiny ups and downs. Its job is to watch the big picture, the overall speed. And when it sees a major change because the load changes, like going up that hill, it steps in and actively controls the fuel supply to keep the speed steady. This table really nails the difference. See, the flywheel is simple. It's just a heavy wheel that's always working. The governor is way more complex, and it only really kicks into gear when it's needed. The flywheel stores energy, the governor controls the fuel. That's why a flywheel is sometimes optional, but a governor is pretty much essential for any engine that has to deal with a changing workload. Now, here is the absolute best way to think about this. On a bike, the flywheel is the momentum that keeps you rolling smoothly between each push of the pedal. The governor? Well, the governor is you. It's your brain seeing that hill coming up and making the decision to start pedaling harder to keep your speed up.
And this is where the engineering just gets so elegant, it's incredible. The governor actually works by using the exact same force we started with, centrifugal force. Our villain from the start of the story actually becomes the hero, and it all comes down to how these two little flyballs move.
Okay, let's just walk through this. So the engine starts to speed up. That makes these balls spin faster, and because of centrifugal force, they fly outwards. As they move out, these linkages push a central sleeve up. That sleeve is connected to the throttle valve, so as it moves up, it starts to close the valve. Less fuel gets to the engine, and the engine slows back down to where it's supposed to be. It's a perfect, automatic, self-correcting system. Just brilliant.
So let's just zoom out for a second. When you combine this idea of balancing with this clever speed control, what you get is the very foundation of our entire modern mechanized world. Seriously, governors are these unsung heroes, working all around us, in places you would never ever expect. The cruise control in your car, that's a governor. The system that makes sure a hydroelectric dam puts out a steady stream of electricity for our homes, yep, a governor. They're what gives you a smooth ride in an elevator and what allows machine tools to work with incredible precision. So the next time you get in your car or even just flip on a light switch, just remember, there are these amazing invisible engineering ideas constantly working in the background, keeping our incredibly complex world in perfect, smooth balance. It kind of makes you look at the world a little differently, doesn't it? What other invisible engineering is out there, just quietly making sure your life runs smoothly?